Okay, and this is part 3 of equation of circle. Today with two examples, example 9 and example 10. Okay, example 9. Basically for example 9, what is given is that we have 2 points A, B that lie on a circle and it's a diameter. Find the equation of circle. Don't. Okay, so first and foremost, what we know is there's A and there's B, like this. Okay, so A is -7 and 2, and B is 5 and 6. So somewhere along this diameter, there should be a midpoint. This midpoint will be the center of the circle. Then, with this center of the circle, you can also find a radius. And you have enough information to get the equation of the circle itself. So now let's start right with finding a midpoint. So what we have is this. So midpoint of AB is equals to -7 plus 5 over 2, 2 plus 6 over 2. So what we will get here is that the midpoint is -1 and 4. To find the radius, we use any point. Okay, we can use the center to B or use the center to A itself. So in this case, maybe I will use the center to A itself. So radius in itself is equals to -1, -7 square plus 4 minus 2 square root. If you simplify, what you get is equals to 2 root 10. Okay, never mind, let me just do this. So there is 7 minus 1, 6, 36 plus 2. So we get square root here of 36. Okay, then 4 minus 2 square plus 4. So what you get is square root of 40. Square root of 40 is square root 4 times square root 10. So you get 2 square root 10 units. Actually, if you leave it at square root 40, is perfectly fine. Okay, now that we have the center and we have the radius, we actually form the equation of the circle itself. So the equation is given by x plus 1 square plus y minus 4 square equals to square root of 40, the radius, and we square this. Simplifying, we get x plus 1 square plus y minus 4 square equals to 40. Now, next thing is explain why this line is a tangent. So part 2 is there's a line 3x plus y minus 21 is equals to 0, and it meets the circle at point B. Explain why is it a tangent. So basically we can explain that if it's a tangent if it's perpendicular, because of the property known as tangent is perpendicular to radius. So once we actually prove that it is perpendicular, we are done. So what we can do here is this. First, what I can do is to find the gradient of AB itself. So if I find the gradient of AB, so the gradient of AB is y2 minus y1 divided by x2 minus x1. So I get 4 over 12, I get 1 over 3. Then from the line itself, 3x plus y minus 21 is equals to 0. I get y equals to -3x plus 21. So, from this general equation of line, I can state that the gradient of the line is equals to -3. Then, what I can say is, okay, -3 times 1/3, okay, this -3 times -1/3 is equals to -1. So, this shows that m1 times m2 is -1. So, I can state that the line is perpendicular to the radius or to the diameter. Okay, in this case the radius, and is therefore tangent. And that is it for example 9. We move on to example 10. So example 10 states this. This one is a bit tricky. This question actually combines certain concepts you have learned in secondary 3 itself. So find the equations of the tangents to the circle which are parallel to the line 2x plus y plus 3. So there's a diagram here. So basically there's a circle, there's this line, y equals to negative 2x minus 3. So there are these other lines that are parallel to this circle. It's not parallel, they are tangent to this circle itself. And what we need to find, okay, is how are the equations of this what I call lines. Okay, so now first and foremost, what I'll state is this. I will say let tangents be y equals to negative 2x plus c. Then you ask me, Mr. Sim, how come the gradient is negative 2? Okay, it comes from here. So from this line here, 2x plus y plus 3 equals to 0. If you rearrange the equation, you get y equals minus 2x minus 3. So the gradient of that line itself is negative 2. So if the tangents are parallel, okay, to this line, it means that their gradient will be negative 2 as well. Hence, I can make the statement, let tangents, okay, be y equals to negative 2x plus c. Now, if these are the tangents itself, what I'm going to do here is this. You notice that we have the equation of the line. So the equation of the line is x squared plus y squared plus 6x minus 2y plus 5 equals to 0. And I also have y equals to negative 2x plus c. There is no way to solve this by doing simultaneous equation, because if I use simultaneous equation, which I will need to do in a while, notice that there are 3 variables to solve. There's x, there's y, and there's also c. In this case, we'll be unlikely be able to solve this, but we'll still try anyway, but by using something we have learned from a previous topic itself. So first, I'll say sub equation 2 into equation 1. So I get x squared plus negative 2x plus c squared plus 6x minus 2y. Negative 2x plus c plus 5 is equals to 0. Then what I'll do here is this. Okay, what I will start to do is to expand x squared plus, inside there it will be 4x squared minus 4cx, then plus c squared, then plus 6x plus 4x minus 2c plus 5 equals 0. Basically, I'm just what I call expanding the brackets over here. If you collect all the terms together, okay, and you rearrange them, what you'll get is 5x squared plus 10 minus 4cx plus c squared minus 2c plus 5. Okay, so that's from the previous page. Okay, we have rearranged this, is equals to 0. Notice that I formed a quadratic equation whereby the coefficient of x squared is 5, coefficient of x is 10 minus 4c, and the coefficient of x to the power of 0 is c squared minus 2c plus 5. Now, the thing here is this. We know that the lines, okay, are tangent to a circle. So tangent means that it meets at one point. If it meets at one point, what this would imply is that if you find the discriminant, there should be real and repeated roots, only one single solution. So by using that idea of tangent meets at one point, the discriminant will produce real and repeated roots. Therefore, the discriminant will be equals to 0. So I will say this, D is equals to 0 as tangent meets the circle at one point. Okay, so if I have that, alright, what I can do is this, b squared minus 4ac is equals to 0. You resolve everything, it will be 100 minus 80c plus 16c squared. If you resolve, what you get is 4c squared plus 40c is equals to 0. You factorize 4c, and then what we get is c plus 10 is equals to 0. Hence, the two values of c is c equals to 0 or c equals to negative 10. So, what we have down here is this. I found the two values of c, so it means that my equation of tangents are y equals to negative 2x plus 0 or y equals to negative 2x minus 10. And I'm done. And that concludes part 3.